So let's jump finally to the most interesting part of this final section of Chapter 6, which is solving radical inequalities. Well, on the next page, you have a multiple choice one. I don't know, should we do one more example before we do radical inequalities? Yay? Nay? Yes? Okay. So let's ignore all except for the problem. So of course we would add 6 first to both sides. Let me rewrite everything. You have 3 parenthesis the fourth root of 2n plus 6 equals 6. And then you would divide both sides. Well, I forgot the parenthesis over here. Then you divide both sides by 3. So you'd end up with, need more space. Let me see, let me go over here. You end up with the fourth root of 2n plus 6 equals 2. Correct? Then what? How do you get rid of the fourth root? The fourth power. How do you get rid of the third root? The third power. How do you get rid of square root? By squaring it, right? What you do to one side, you do to the other side. So the fourth root and the fourth power cancel out. You have a nice, beautiful 2n plus 6 left over. Equals 2 times 2 is 4, times 2 is 8, times 2 is 16. And then, of course, you subtract 6. So you have 2n equals 10, which means n equals 5. n equals 5. This is our answer. But, of course, we should double check it, right? So let's take the answer 5, plug it back in. What's 2 times 5? What's 10 plus 6? 16. What's the fourth root of 16? 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. Once again, when I plug it in, I end up with the fourth root of 16, and that is really the number 2. So what I really have is 3 on the outside times 2. What's 3 times 2? 6. And then take away 6? 0. So it does work out. I mean, I didn't show all my work. I kind of checked it in my head. But 0 does equal 0. It is a true statement. So you know for a fact that n does equal 5. They explain all that right there. The answer would be C. Moving on to the most interesting part of the section, which is solving radical inequalities. So listen up, guys. When we have an inequality, we're talking about an area of answers, not just one answer. It can't be x equals 3 or x equals negative 5. You're talking about an area of answers. X is greater than something, x is less than something, or it might be an area of answers that's between 2 values. So step 1 is to make sure that the inside value of the square root, which is called the radicand, I don't know if you see that right there, the inside value of the square root is called the radicand. You got to make sure that that radicand is not negative at the end of it all. So how do we make sure that 5x minus 10 is not negative? Well, you're going to write it like this. You're going to write it as 5x minus 10 is greater than or equal to 0. That's the only way that you could assure that this inside value is not negative. That you say that it's greater than or at least equal to 0. So the first thing to do when you have a radical inequality is to set your radicand to be greater than or equal to 0. And that's what it says right here. First, set the radicand to be greater than or equal to 0. And then you solve this inequality, right? Plus 10, you get a 10 on that side. Divide by 5, x, you don't flip the inequality. X is greater than or equal to 2. Of course, if you divide by a negative, you have to flip the inequality. But anyways, in order for the inside value to not be negative, your x has to be greater than or equal to 2. So technically, this is a part of our answer. X is greater than or equal to 2. And then we move on to step 2, which is actually solving the whole thing. You actually have to solve the whole thing. So how do we solve this whole thing? Just the way you would before, like if it were an equation. Subtract 3 here, subtract 3 over there. 8 take away 3 is 5. And how do we get rid of this radical value? You square it. So let me show some work here. They don't really show it. You square it, and what you do to one side, do to the other side. That's how they get 25. And then you would add 10 to get rid of this minus 10, and add 10 over here. That's how you get 35. Bring down the 5x. Final step would be to divide by 5, and that's how they get x is less than or equal to 7. You guys understand that, right? Okay, so what we need to do is set up our a number line. Okay, so let's set up a number line. So we set up a number line, and we need to put these values of 2 and 7 on the number line. So let's say 2 is about right here, 7 is about over here, 0 is clearly on this side. But what we need to do is, well, I mean, you could follow what it says here. X is greater than or equal to 2. Greater than or equal to would be a solid dot at 2 going that way. And the other one's x is less than or equal to 7. Solid dot at 7 going this way. So we're assuming that the answers are in here, because that's what these answers are. But remember, radicals sometimes have extraneous answers. So maybe it's not just this area. Okay? So what we need to do is test points. Okay? I hope everybody's paying attention. This is what you need to do on Thursday's test. And it's going to be on the midterm next week also. On radical inequalities, you need to test answers. So you need to test values that are on the outside and on the inside. So a clear answer number to test would be 0, which is clearly on the outside. So let's test 0 with this original inequality, radical inequality. If I plug in a 0 right there for 5x, that'll be a 0, and 0 minus 10 will be an imaginary value, correct? Yeah? 0 minus 10, the square root of negative 10 is going to be imaginary, and that just messes it all up. So we know that 0 did not work. That's not an answer, okay? Let's test the value that's on the inside. Give me any number that's on the inside in between 2 and 7. 4. Okay, so if you pick 4 and you plug it in, 4 times 5 is 20. 20 minus 10 is 10. And then you're going to have to do the square root of 10, and you're probably going to do that on a calculator, all right? You'll get a decimal value. The square root of 10, so you really have 3 plus the square root of 10 is less than or equal to 8, and the square root of 10 is, on the calculator, 3.162, and it continues, but I'm just going to write that. So you have the plus 3 in front, and as you can see, it is less than or equal to 8. So in here, it's yes, it's a true statement. Now, if you test any point on the outside, like let's say 100, that's way out here. Or, I mean, you could do 9, you could do 8, any number you want. But if you pick a number on the outside like 100, then it would be 5 times 100, that's 500, which is 490. The square root of 490 is something huge, which is not going to be less than 8, right? So out here, it's also a no. So once you know that your answers are between here and here, you're going to write your answer as a compound inequality. And the compound inequality will have the x in the middle and the less than symbols with the line underneath it. It's always opening to the right. Okay? So what this really says is x is greater than 2, x is greater than 2, and x is less than 7. So there's your compound inequality. This would be your answer for that. Now, you're not always going to get compound inequalities. And if you wanted to see the explanation that the book gives, you could turn the page and, whoa, let me get that out of the way. Turn the page, and that's exactly what they do. They do the number line that we drew. They put the 2 and the 7. They drew the areas together, but they also checked values that were on the outside and on the inside. Notice they checked x equals 0. It didn't work. They checked x equals 4. It did work. And they checked x equals 9. It did not work. So the book explains it all. I hope that helps. So let's do number 21 from page 432. It's the last question of your homework. So what was step 1 when dealing with radical inequalities? What do we do? What's the first thing to do? That's not when you start solving, yes, for sure. But even before that, you want to make sure that your radicand value, which means the value inside the square root, you want to make sure that the radicand value is not negative, right? So the very first thing, step 1, is to set up your radicand to be greater than or equal to 0. So you're going to put 9 minus 5x. You need it to be positive, which means you need it to be greater than or equal to 0. Okay, so when we solve this thing, you're going to subtract 9 on both sides. So if you go minus 9 here, minus 9 over there, you're going to end up with negative 5x is greater than or equal to negative 9. And then you're going to divide both sides by negative 5. And when we divide by a negative on an inequality, we have to flip the inequality symbol. So that's going to be x is less than or equal to, not greater than or equal to, positive 9/5, which you could also say as a mixed number is 1 and 4/5. So this is right here part of our answer. X is less than or equal to 1 and 4/5. And then we have to go back to the original radical inequality and solve that. So I want to subtract, I want to actually add 2 to get rid of that minus 2. So if I go plus 2 here, it'll cancel. Plus 2 over here, I'll get 8. So I'm going to have the square root of 9 minus 5x is greater than or equal to 8. And what do I do next to get rid of that square root? You square it to the second power, which you do to one side, you do to the other side. So on the right side, you're not going to have 16, you're going to have 64. So your new inequality will be 9 minus 5x is greater than or equal to 64. And then you subtract 9 and subtract 9. You're going to have negative 5x is greater than or equal to, what is that, 55? And then at the very end, you divide by negative 5. Divide by negative 5, and you will get your final answer, x. You have to flip the inequality, less than or equal to negative 11. So you have those two answers. So we have those two answers, and some of us might be in a rush during the test, and we just jump to the number line, put those on there, and we write that as an answer. But you got to check. You have to check your answers. Some of them might be extraneous solutions. So where is 1.45? Well, let's say 0 is right here. 1.45 is almost at 2. So let's say that 1.45 is about right here. Or not 1.45, I'm saying 1 and 4/5 is what I should be saying. 1 and 4/5 is actually 1.8. But anyways, that's that blue dot right there. And it does say x is less than, okay? And the other one is at negative 11. Let's say it's way over here, negative 11. And it's also less than. Okay. So they're both going in the left to the left, which means that your answer is going to be on the overlap piece. All right. Now, if they would have been going this way, if this would be going this way and this would be going this way, they would overlap in the middle. So you would guess that the middle piece is your answer. But in this case, they're both going this way, so they really overlap over here only on this piece. So right now, our best guess is that that inequality is the answer, which is x is less than or equal to negative 11. All we got to do is double check by plugging in values to test and make sure that those answers on the left of negative 11 work. So zooming out a little, if I tested the value of 0, which is clearly between them, let's just make sure that this doesn't work. Plug in 0 right here. 5 times 0 is 0. So you have 9 take away 0, which is just 9. The square root of 9 is 3. Negative 2 plus 3 is not greater than 6. So yeah, 0 didn't work, right? Let's try negative 12, which is clearly on the left side. Okay, on a calculator, 5 times negative 12, that's going to be negative 60, but with the minus sign, it'll be positive 60. So you have really 69 in here. And if you do the square root of 69 on a calculator, let me see, the square root of 69, you end up with 8.3, okay? Of course, 8.306623863, but I'm just going to say 8.3. So you really have, double checking, negative 2 plus 8.3, it's supposed to be greater than or equal to 6. However, negative 2 plus 8.3 is less than 6. Oh no, it is greater than 6. It's 6.3. So it does work. Okay, so to the left is the correct answer. And if you were to test the point out here, it wouldn't work. So x is less than or equal to negative 11 is the correct answer and the only answer.